So since we're given opposite angles, we need to look at our theorems. Opposite angles are congruent. Is that true in number 1? Yes, it is. So since it is true, what you would write down is opposite angles are congruent. My screen is frozen, which is lovely. Ta-da! So you would write that as the answer. There is an official name for the theorem, but I don't care that you learn the theorem name. What I do care is that you know that opposite angles are congruent. So because of that, this is a parallelogram. Then you would move on to the next one. Are we given sides, angles, or diagonals? We're given diagonals. What do we notice about our diagonals? They're cut in half, right? Because this half is congruent to this half to this half. All right. So because of that, you would write down diagonals bisect each other. That would be your answer. Diagonals bisect each other. So there's an entire section that looks like this. And you use this list of 5. I am recording, so if you did not write down this list of 5 or you don't remember it, you can come back to here on my YouTube. 3 and 4, you'll have a section like this. It's very simple. You'll find the value of x that makes the quadrilateral a parallelogram. So in number 3, I see these triangles. What do these triangles mean? Parallel. So I have 2 pairs of parallel lines. Okay, if this was a parallelogram, what would 3x plus 5 equal? It equal 41, because opposite sides would be congruent. So then you would solve. What would we do next to solve our problem? Subtract 5. So 3x equals 36. What would we do after that? Divide by 3, so x equals 12. Welcome back, Austin. It's all good. Number 4, at least he's awake. At least he's talking to me. I appreciate that more than someone who stares at the desk. You know what I mean? I got you. Number 4. If we look, I see we have 2x and 2x. They're opposite sides, so they should be equal. Could I set them equal?
Yes. No. No, ma'am.
No, you can't. Because sorry, my eraser's in the way. Because it's the same thing. You would subtract 2x and you'd have nothing and it would not make any sense. So you cannot do it this way. So what is a different way we could solve for x?
Plus 2 equals 5x minus 6.
Yep, set my other 2 sides equal. So what would I do next to solve? Replay, or resume. All right, so we set them equal. What do we do next? Thank you. Beautiful, Gwen. Beautiful. 2 equals 2x minus 6. What do we do next? Add 6. I heard you, Allie. Appreciate it super much. Plus 6. I know I ran out of room, but 8 equals 2x. So what does x equal? 4. So that's what you're doing when you go to your homework. First section, your answer will be words. Second section, they're numbers. All right? We're going to look at the problem at the top of your page. It should look very familiar. You do have a problem just like this on your quiz. I promise you with all that I have. All right? So, we're going to talk about it. I want you to write that this is a parallelogram. It doesn't give you the instructions on your notes, but on your quiz it's going to say, here's a parallelogram. So we know 4 properties about a parallelogram. What was one of those properties? Opposite sides are congruent. They're congruent and parallel. I'm just going to throw it out there.
Opposite angles are congruent.
Opposite angles are congruent.
Diagonals.
Okay. People always forget this last one. Diagonals bisect each other. That's great. Yeah. So 4 is about consecutive angles. What do you know about consecutive angles?
Show that one pair is opposite.
They're supplementary, which means they add up to 180 degrees. So we use these to solve this picture. CD, is this a side or a diagonal?
Side.
It is a side. It's this side right here. We know that opposite sides are congruent. What is opposite of CD?
AB.
AB, which is? So CD will be 16. All right, then we got AD. Is this a side or a diagonal? AD. Are we listening to me?
AD is a side.
AD is a side. It's because they're trying to...
Oh, we're on 9.
AD as in dog. Alright, AD is across from BC. So the length of AD is 7. Now, Corey, AE, is this a side or a diagonal? It's a diagonal. What is the measure of the other half of the diagonal? 7. So what's the measure of AE? 7. All right, this next one, BD, side or diagonal? Diagonal. It's the length of the entire diagonal. What is the only measurement I'm given in reference to this diagonal? 10.2, which is this portion. So what's the other portion of it? 10.2. So what's 10.2 plus 10.2? Correct. All right, then we got BCD. BCD, which is this entire angle. What other angles am I given in this picture? 120 and 43. Which one will help me figure out what angle C is? Angle A, which is 120. What do I know about angle A and angle C? They're opposite and congruent. So what's the measure of BCD? 120. I'm going to write it up here so we'll remember. All right, well, our next one we got ABC. A, B, C. It takes me everything not to sing that song. Y'all know which one I'm talking about, right?
Michael Jackson's.
Jackson 5. There's a massive difference. There's 5 of them. When I was in elementary school, I went to Lone Star Elementary, which is near Sandalwood, and we live over here. So every day I would listen to my cassette tape of Jackson 5. Good time. So I know them all. Anyways, it's a big deal. Anyways, so what do we know about angle B? It's opposite of angle D. Do we know the measure of angle D? No. We only know a piece of it, which is this one. Does that make the other... Actually, let's ask Andrew. Last time you didn't listen to me. If this is 43, is the other piece 43?
No.
No. So, we don't know the measure of this angle. What are we given that would help me find it? My consecutive angles. A and, what is it, D? A and B are consecutive. C and B are consecutive. Well, what were the measures of A and C? 120. So how would I find what angle B is? Subtract from 180, because they are supplementary. 180 minus 120 is? 60. So that means ABC is 60. I'll write it up here. Almost done. Then we got ADC. ADC. All right, so what's the measure of ADC going to be? 60, because it's the same as angle B. And then DBC, which is DBC. It's actually not going to be 60. It is going to be what?
17.
Where are you getting 17 from? But they're alternating interior. This one is 17. This one is 17. So this one's 43. Alternate interior. Calm down back there, buddy. Alternate interior means you have 2 parallel lines and a transversal, aka a line, cutting through them. And this forms the relationships you learned in Chapter 3. So 43 and 43, 17 and 17, they're alternate interior. So that means DBC is 43. That's it. Ta-da! So we're going to move on. Today we're learning about special parallelograms. So does that mean what we learned today are parallelograms?
Yes.
Yes, they are. They're just
Special.
They're just special. You actually know them already. We're still on page 1. Yep. We're on the bottom of page 1. We're going to talk about them. First thing is a rhombus. You'll see in the bottom-ish left corner there's a picture of a rhombus. You want to know that it's a rhombus and it's a parallelogram with 4 congruent sides. You want to write the tick marks. On your test, it is going to literally ask you what is a parallelogram with exactly 4 congruent sides. And you will need to answer a rhombus. promise you. It's the first section on your test. So a rhombus just has 4 congruent sides. That's all we know about it so far. What does the next picture look like?
A rectangle.
A rectangle. So directly to the right is a rectangle. A rectangle has 4 right angles. That's what's special about a rectangle. It has 4 right angles. All right, now let's use our 9th grade minds. What is the bottom one? A square. So what do we think a square is?
4 congruent side and 4 congruent.
Yes and no. 4 congruent sides and 4 right angles. Technically, they are congruent, but in specific, there'll be 4 right angles. So perfect. You got 4 congruent sides and 4 right angles in a square. You will literally be asked to classify a polygon or a parallelogram, and it'll be one of these options. And it is actually one of the most missed questions on the test. All right, so here is what you're going to learn. What are all of these classifications of? They are quadrilaterals. What else are they all? Parallelograms. Parallelograms. So because they're all parallelograms, here we go. So because these are all parallelograms, the person listening to this probably just heard me say that for the 4th time. All of these 4 properties, the opposite sides are congruent, the opposite angles are congruent, the diagonals bisect each other, all that, these apply to all of these shapes. Do we understand that?
Yes, ma'am.
Okay, good. So we're going to learn properties about a rhombus. But here's what you need to understand. A square is also a rhombus. Why is a square also a rhombus?
Because it has 4 right.
Has the 4 congruent sides. A square, this blows the mind of many. A square is also a rectangle. And most people like to deny it. I know that's weird. But because it has 4 right angles, and the definition of a rectangle is a parallelogram with 4 right angles, it is also a rectangle. So today you're learning the properties of a rhombus. They also apply to a square. Tomorrow you're going to learn the properties of a rectangle. Guess what? They also apply to a square. There are no extra properties for a square. They just have all the properties of these 2, as well as the 4 of a parallelogram. That makes sense? They will make sense when we all get there. Let's classify a triangle. Classify a triangle. What am I saying? Words. You can flip if you want. We're not there yet. Here's a Venn diagram to show those who are extremely visually minded. Emily. Here are all parallelograms, correct? So all of them have opposite sides that are parallel, opposite sides that are congruent, opposite angles congruent, all that jazz. Here are all my rhombuses. Here are all my rectangles. And where they come together,
Purple.
what is the shape? A square. When a rhombus and a rectangle get together, have a baby, it's a square. Okay? So, let's talk about it. We're going to classify this quadrilateral. So our options so far are just straight up a parallelogram. I'm not going to write it all out. Got a parallelogram. We got a rectangle. We got a rhombus. 2 seconds. And we got a, square. So here are our options. What do we first notice about our picture here? We have 4 congruent sides. So what can we eliminate if we have 4 congruent sides? We can...
Square and rectangle.
What? Square have 4 congruent sides? Just by this one fact. Don't think ahead. By this one fact, we can eliminate rectangle. We can also eliminate parallelogram in general. Parallelogram is super broad. It would be if none of these were happening. What else do we notice about this picture?
It doesn't have any right angles.
Well, we don't have not all right angles. So what can we eliminate for that? a square. So no square. So what is our final answer? A rhombus. So all of this is my answer. Why is all of it my answer? It says explain. So it's a rhombus because all the sides are congruent, but not all the angles are right angles. All right, that's it. Moving on to rhombus properties. Okay? Right after the colon of rhombus properties, I want you to write that it has all the properties of a parallelogram. So right after the colon, so I'm going to clear this. So you know how it says rhombus properties, and then there's a colon. I want you to write that it has all parallelogram properties. Parallelogram properties. All right, now you're going to learn two properties of a rhombus that are added onto that. Okay? You need to listen, or you're going to be writing forever, and I'm not going to wait for you forever. We understand each other? Do a lot of you read math very well? Like, you can look at your book and understand what it's saying? No. Okay, so not a lot of you do. And that's okay. I can read math very well, and I can put in the layman's terms for you. If you like to read from the book, you do you. If you don't like to read from the book, please listen to your math teacher. Whatever you want. So, it says a parallelogram. We're not writing it. A parallelogram is a rhombus if and only if its diagonals are perpendicular. What does perpendicular mean? Two lines intersect and form a right angle. So here's what I want you to write. This is a rhombus property. The diagonals are perpendicular. The diagonals are perpendicular. So you're writing the diagonals are perpendicular. That's the first property. So in a little bit, you're going to be asked to find the measure of the angles where they intersect, the two diagonals intersect. It's always going to be 90 in a rhombus. What other shape will this apply to? A square. Yeah, a square. All right, next one. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So, what we know about diagonals right now, we're not writing anything yet. Diagonals bisect each other. We agree? They cut each other in half. Here's what in a rhombus they also do. They cut angles in half. So what will happen is each angle will be cut perfectly into two. So what you're going to write is diagonal bisects opposite angles. That is the second property of a rhombus. All right, and then we're going to use it. So diagonals bisect opposite angles. Here we go. So because a rhombus is a parallelogram, it's got those two properties. But we also know the opposite sides are going to be, I know we hear it over and over again, but some people still don't listen. What do we think? Opposite sides are? Congruent and parallel. Opposite angles are? Congruent. What about consecutive angles? Supplementary. And then, think back to the old property. What do we know about diagonals? They bisect each other. Okay? Now we know in a rhombus, they also bisect the angles. So it's kind of all a bunch of bisecting. So let's look. For your homework tonight, when you get to a problem from this section, it will look just like this picture, just a little bit different. But here's what I'm going to ask of you to do. You're going to write down the four properties when you get to this section. Okay? So the all parallelogram properties, diagonals, perpendicular, all that jazz. And then you're going to draw the picture. This will help you be able to draw on the picture. Okay? So we're going to look at this. To answer, you need to tell me which one's which. So the measure of angle 1 equals, the measure of angle 2 equals, measure of angle 3 equals, measure of angle 4 equals. So let's look at 1. 1 is stuck between my two diagonals. But what do I know about the diagonals of a rhombus? They bisect these angles, but that doesn't help me. They bisect these angles down here, but that doesn't help me right now. Someone did say what does help me. They're perpendicular. So where they intersect, they form 90 degrees. So all of these are 90 right here. Pause, apparently. It is what it is. So, because the diagonals are perpendicular, angle 1 is going to equal 90. The diagonals do bisect the angles, but it didn't really help me right here. Angle 2, I can actually find 2 and 3 at the same time. 2 and 3 will be the same measure because this diagonal cuts angle A in half. So whatever angle 2 is, angle 3 will also be. To figure out what that is, we can look across, because what do we know about opposite angles? They're congruent. So if this is 61 and I know that I'm bisected here, what's the other portion of angle C? 61. So what's the measure of 2 and 3? 61 and 61. Because my angles are bisected. The last one, there are 2 ways to figure this out. 2 ways. I will show you one way. Because the second way is shorter, but if you're wrong twice. Does that make sense? So like on the second method I'm going to show you, if you were wrong with the first angle, you're going to be wrong on the second angle. Does that make sense? I'll show you. We're trying to find angle 4, which is a part of this angle. I know that angle D is cut in half. Do we agree? So what relationship does angle D have with angle A? They're consecutive, which makes them supplementary. What's the measure of angle A? The whole angle. 122. So could I find what the measure of angle D was? Yes, how could I find angle D? Subtract from 180. So 180 minus 122. Don't worry, I'll do it for you. It's 58. So that means that's not the answer, though. That means all of angle D is 58. Think about it. Angle D is bisected, which means it's cut in half. So how could I find what the left half of the angle equals? Divided by 2. There's a second way to do it. Put your hand down. So we're going to get 29. Here's the second way. So if angle 1 is 90, angle 3 is 61. Think about this. What shape does this make? A triangle. How many angles do you have in this triangle? Well, how many angles do we know of right now? We know 2 of them. We're missing 1 of them. So how would we find the missing angle?
You add them up.
And then what? Subtract 180. So 61 plus 90 is 151. 180 minus 151 is 29. This is the simpler way to do it. But here's why I said if you were wrong once, you're going to be wrong twice. I used 61. If 61 was incorrect, my final answer would be incorrect. If 90 was incorrect, or whatever you put, it'd be wrong again. Does that make sense? So you can do it this way. This is the way I do it with the triangle, but it's really and truly up to you. Okay? At this point, we are going to be done.